Hi, everyone. My name is Ryan Voltz, and I'm a radio scientist at MIT Haystack Observatory, where I study the upper atmosphere using radar and radio techniques. But today I'm going to talk to you about something that is born out of that experience of my day job, and that is managing GNU radio installations with Conda. For anyone out there with a really short attention span, I'm going to give you everything you need to know on this one slide. So if you get one thing from this talk, let it be this. You can install GNU Radio for Linux, macOS, or Windows using my Radio Conda installer, which is on my GitHub at the link shown on the screen. And all the information that you will need to use it can be found at that link or at the GNU Radio wiki. Search for Conda install. Now, to get into the meat of it, I'm going to start you off with a little bit of an introduction to Conda in general, and then we're going to talk about how to get started with GNU Radio and Conda, which is geared towards your typical users. And then to finish it off, we'll dive in with some more advanced topics for the more adventurous. Some of you may be thinking, Conda, I think I've heard of that. Isn't it that Python distribution for data science? No, that is Anaconda, which is the world's most popular data science platform according to Anaconda Inc., which makes it. Or you might be thinking, isn't it that package installer for Python? No, that's pip. Or isn't it that tool to create isolated Python environments? And no, that's virtualenv. But at the same time, Conda also kind of is all of those things. So what Conda is it's a tool for installing software packages within an isolated environment. And a key feature is that it is cross-platform for Linux, macOS, and Windows. It is written in Python, which is why you are often hearing it associated with Python. But it can package any software. It's not restricted to Python. And it is developed by Anaconda Incorporated, which is why it sometimes gets confused with Anaconda, the distribution. One thing Conda does is it allows you to create and activate isolated environments. So you can type conda create -n and then the name of an environment, and it'll create a directory for storing that environment. And then you can type conda activate and then the name of the environment, and it'll put you at a prompt where programs within that environment are on your path, so you can execute them without getting interference from your base system. Another thing you can do with the conda command is install packages. So from within an environment, you can type conda install and then the name of the package, in this case Python, and we're specifying that we want it equal to version 3.9, and it'll present a plan for which packages it wants to download and install, and if you approve, it will install those into your environment. Another important task for managing these environments is listing all of the installed packages that you already have. So from within an activated environment, you can type conda list, and it'll list all of those packages, including their versions and where they came from. So you can see here that after that last install command, we have Python 3.9, and it's 3.9.7, and we also have all of the other packages that Python depends on. So that's just a taste of the basics of what Conda does, but I can recommend that you follow this link and find the official user guide, where you can see not only more commands that you can use with Conda, but also the theory of how Conda works and how it's designed. So it's a really great resource, and I recommend that you check it out if you're interested. Now, it's possible some of you maybe have already used Conda and you walked away from it being not very impressed, thinking it was kind of slow and difficult to use because of that. Well, I have good news for you, because there now exists another tool called Mamba, which is a fast cross-platform package manager, which is a drop-in replacement for Conda. It is written in C++, and that makes it faster and much more pleasant to use these days. So I recommend that you have both installed, but use Mamba preferentially, especially for installing packages or creating environments, because its dependency resolution is much quicker. And in order to install Mamba, you'll probably just use a conda install command. So something like conda install Mamba, but you specify -n base to install it into the base environment, and -c conda-forge to get it from the conda-forge channel. And we'll talk about channels in a second. Now that you know a little bit about conda, you might be thinking, well, why is this relevant to grcon? Why has he spent 5 minutes talking about this? Where's the radio? Well, it's relevant because installing GNU Radio is a hurdle for many. And often people want other packages too, not just GNU Radio, and those packages have to be kept in sync because things are compiled with specific versions of GNU Radio. And building from source is sometimes required or recommended to do this. And this is a known problem, and it's why PyBombs exists. So conda makes installation easier. You can get up-to-date cross-platform packages that are a command away, and you can even manage the whole software stack, so not just GNU Radio, but all of the out-of-tree dependencies and other stuff that you want to use with GNU Radio. And even expert installation hurdlers who's very used to building things from source, you can benefit from conda as well. And the great thing is that this is a tool that is sustainably supportable by the entire community. So it's not just going to be on one person's back or my back to keep it operating and keep packages up to date. That said, we're still not quite done with our introduction to conda. There's a few concepts that I want to cover first, talking about environments, channels, and distributions. First up is defining a conda environment. An environment is a managed directory. Sometimes we think of these as an installation prefix, and they are usually found in the envs folder within your base installation. That's by default, but you can actually create environments at any location. They're structured in the Unix style, so you have your standard bin, lib, include paths within that directory. And on Windows, all of those Unix-style paths are actually found in a library subfolder. And these files are hard-linked, so there's no cost to use the same packages within multiple environments. So creating environments with duplicate packages is not going to cost you any more disk space. A conda channel is a collection of packages that you can download from. And these are usually hosted on Anaconda Cloud, which is anaconda.org, or there's a new tool called Quetz, which will allow you to self-host a channel of packages. Some examples of channels are the defaults channel, which is put out by Anaconda Incorporated. There's also the conda-forge channel, which is the primary collection of community-supported packages. There's also focused communities of different packages, one of them being BioConda for biology and bioengineering. And on Anaconda Cloud, you can also have individual users with their own channel. So I have my own channel, Ryan Boltz. And it's generally recommended to use only one channel, or if you want to use multiple channels, set them with a strict priority so that you're not mixing and matching packages that might conflict. So you can install from a specified channel with your conda install command by passing the -c flag and then the channel name. And it's also possible to set the default channels for a particular overall conda install or for a particular environment by modifying your conda configuration and adding the appropriate settings. And finally, we have conda distributions, where distribution is an installer for a base environment with a specific collection of packages. I've already mentioned Anaconda, which is a distribution focused on data science, where all of its packages are in the defaults channel, and it's made by Anaconda Incorporated. There's also the mini conda distribution, which is a minimal base with just conda and only the things conda needs. And it's configured to install more packages from the defaults channel, and it is also made by Anaconda Incorporated. But then we also have the mini-forge or mamba-forge distributions, which are a minimal-based distribution with either conda or mamba as the main package manager. And these are both configured to install from the conda-forge channel by default. And these distributions are made by the conda-forge community. And then finally, we have my Radio Conda distribution, which is a collection of open source software radio packages. It is also configured to download packages from the conda-forge channel, and this one is made by me. Now you know what conda is, so in this next section we're going to talk about how to get started for using conda, in particular with GNU Radio. The first step is to download a distribution so you can get started using the conda command. I think the best way to start is to use Radio Conda because that'll have most of what you need and you won't have to dig too much into using conda itself. But if you want to do that or you want a little more flexibility, I do recommend the mini-forge or mamba-forge distributions. So what you'll do is you'll go to either one of these GitHub sites and you'll download the installer for your operating system and architecture. If that combination is not available, then seek me out and we can talk about trying to make it available. Next, you'll need to run the installer that you just downloaded. So on Linux or macOS, this will be executing the installer from a command line, or on Windows and sometimes macOS. If it's a graphical installer, you can just double-click it. You'll have to go through a few steps, the first of which is to agree to the license, and then you'll have to choose where to install. Usually the default is okay, and it's probably a good idea to put this in some home or user directory. Then it'll ask if you want to initialize or if you want to add conda to your path. And you'll probably want to answer yes to this, because that'll make the conda command available in your terminal without having to do additional configuration. Then on Windows, it'll ask if you want to use this as your default Python, and you'll probably want to answer no to that, because you don't want to use this as your Python unless you specifically activated that environment. So on Linux and macOS, in order for that answer to be no, you'll actually have to go in and change the configuration after you've installed. And so you'll want to set it to auto-activate the base environment to false, so that it doesn't load up this base conda environment whenever you open a terminal. To use your new environment on Windows, you'll want to open up the conda or mini-forge prompt, which is installed into your start menu. Or on Linux and macOS, you'll just open up any terminal, and then because you answered yes to that initialization question during the installer, you can use the conda command already and type conda activate base, and that'll put you into the base environment. It's a good piece of advice to avoid installing things into the base environment. A shorter package list is easier to manage, and the base environment ideally includes only what it must, i.e. conda and or mamba and what those need. This is because environments are cheap, so it's not a big deal to create new environments for the programs that you actually want to use. And this could be a reason to prefer mini-forge over Radio Conda, because the mini-forge distribution is that small base distribution, whereas Radio Conda has everything installed in the base environment. So if you do have mini-forge, you do opt for that, you can create and activate another environment with all of the Radio Conda packages by doing a conda create command and name that environment Radio Conda. You can tell it to install from the conda-forge channel and my personal channel. And you only want it to install the dependencies of the Radio Conda meta package, and that'll install all of the packages that come with Radio Conda. And then you can activate that Radio Conda environment, and then as you're using it, if new packages come out, you can upgrade them with the conda upgrade command by using the --all flag. So what about GNU Radio in particular? How do you get started using that with conda? Well, these are all the packages that I have added so far to conda-forge. That includes GNU Radio, which I broke up into a few of its component pieces, so that you don't have to install all those dependencies at once if you don't want to. There's also some out-of-tree packages, GNU Radio Osmo SDR, GNU Radio Satellites, and GNU Radio SOAPy before it came in tree. Then there's Digital RF, which is a package I maintain for MIT Haystack Observatory for recording and storing data. And there's GQRX for exploring the spectrum. And then a bunch of packages for hardware support. So that includes the AirSpy devices, libIO and the Pluto device, Lime Suite for the Lime SDR devices, RTL SDR, Edis UHD devices, and the SOAPy modules that support all of those. These GNU Radio packages are compiled against both GNU Radio 3.8 and 3.9, so you can choose which version you want for now. And so this list is nice, but more packages would certainly be better. And so I'm adding more packages when I have time or as particular needs arise, but I'm definitely always interested in help. And hardware testing would be particularly helpful. I've already covered all of the devices that I have or have access to. So if there's a device that you're interested in that's not on this list, please help me test it and we can get a package going. Actually, using GNU Radio from a Conda environment is as easy as activating that environment and using GNU Radio like you normally would. But if you have more questions, here's a list of resources that you can turn to. There's the GNU Radio Wiki and the Conda install page. There's also more information on my Radio Conda repository, in particular for getting the different hardware devices set up and running. Or you can also ping me on the GNU Radio Matrix chat. And if you encounter a bug using some of these packages, and it's a bug in particular with the packaging, you can find the repository for that particular conda-forge package. It has its own feedstock repository under the conda-forge organization, so just Google for that and report the bug there. And if it's not a bug in the packaging, definitely report that upstream. I'm sure they'll be appreciative. All right, now for the more adventurous out there in the audience, in this last section, we're going to talk about a few more advanced topics with the goal of giving you everything you need to know to help me make some more packages related to GNU Radio and maintain them going into the future. Packages are created using a conda recipe, and a recipe is just a directory with a few basic files. There's the recipe metadata file, or meta.yaml file, where you have the name of the package, the version, and the build number. It has the download URL. It has a list of dependencies for the build, host, and run environments when you're building it. It has some testing commands to make sure the package works correctly, and then it has some descriptive metadata. The build scripts for Linux and Mac OS are build.sh shell scripts, or for Windows it's the build.bat batch script. And these lay out the build steps for Linux, Mac OS, and Windows. And so this is your typical sequence of, say, cmake, and then make, and make install. And then they will install to the prefix or library prefix directory as appropriate for Unix or Windows. The tool that executes the recipe to create a package is called conda build, and so you'll want to install conda build into your base environment, and then you can run it on the recipe directory, like conda build, and then the recipe directory. The steps that it goes through to build a package are it will create and activate the host environment according to the list of host dependencies that you included in the recipe. Then it'll create and overlay the build environment according to the build dependencies. And then it will execute the build script. And then it'll take the installed files that you put into that host environment and package those into a tarball. And then it'll install that package into a new test environment and run the test that you specified. And if it passes, then you have a successful build. On the right here, you can see some of the contents of one of these package tarballs, which is just the files as they will be installed into the environment, plus an info directory where things like the actual recipe itself, the licenses for the source code, and the metadata about dependencies and whatnot are stored. So here I'm going to use the GNU Radio Satellites recipe as an example. You can see the full recipe on the conda-forge GitHub if you search for the GNU Radio Satellites feedstock. So this is the top of the meta.yaml file, where we can see we're defining the package name and the version, the source of where the source code is downloaded from. And another key takeaway here is that a recipe is rendered in two different steps. So the first step is to either keep or drop a particular line based on selectors. And you can see one of these selectors in the third to bottom line, which is that comment followed by some brackets and an expression. So if that expression is true, then that line is kept. And if it's false, then that line is deleted from the recipe. And then the next step in rendering is to fill in the template with all these variables in double brackets or bracket and percent signs that you see here. And this is using the Jinja templating language. And once you've rendered all of that out, you have a complete full meta.yaml file. The next section in the meta.yaml file is the list of requirements. Here divided into the build, host, and run environments. And you can see we use the selectors here to specify different requirements for the different operating systems. It's important to note that host dependencies can automatically add to the run dependency list if their recipe specified a special value in its own build, run, export section. The section after the requirements is the test section, where you can see we can run different commands, that if any of them fail, then the tests fail. So typically we might check to make sure that the executables run correctly, or to make sure that certain files exist within the packaged tarball. And then another typical test is to just try importing some different Python packages. So in this case, we're just going to import the GR Satellites Python package. The last couple sections of the meta.yaml file are where you provide some informational metadata, including web pages that are useful to link to, the license for the source code, and the summary and description of the package. And then also, for conda-forge in particular, some extra information about who's maintaining this package. You can find much more about writing these meta.yaml files if you search for conda build meta.yaml. There's a great documentation page here that I refer to all the time to remember how to fill out all these different fields. The other half of the recipe is the build scripts. And you can see here that it's your typical steps that you walk through when you build from source. You make a build directory, you call cmake, and in this case we have to pass it some particular arguments for installing and building into a conda environment. And then you just, do your standard build and then install steps after that. And you'll notice that these scripts use some environment variables that have been defined ahead of time by conda build. And I've also referred to this documentation page a lot. So search for conda build environment variables, and that'll tell you everything you need to know about that. Writing a recipe is the preferred way to install into a conda environment, but it's also possible to build packages and install them into an environment without using a recipe. I generally wouldn't recommend this because it may be hard to maintain, but it can be useful for development. So the general build procedure is just like a normal build from source, except that you want to install your dependencies into a conda environment. You want to activate that environment. And then when you build, you want to tell cmake about the environment. So for an out-of-tree module in particular, you want to start within the out-of-tree module source directory. And then we'll use Bomba to create a build environment. We'll install into it the GNU Radio package, of course, and then also a special meta package called GNU Radio Build Deps, which will install the typical dependencies that you also need along with GNU Radio. And then if there's any particular dependencies for your out-of-tree module, you want to install those as well. Then you activate that build environment, and then you go through your typical build steps. You create a build directory, you enter the build directory, you call cmake, and in this case we have to tell it about our conda prefix, where we want to install into and where we want to get libraries from. And then you just tell it to make and make install, and that's all there is to it. You can find more details, including Windows instructions, since this is in particular for Linux in this example, on the wiki. Again, search for conda install. If you want to build GNU Radio itself in a conda environment, it's the same basic steps as with an OOT module, except in this case there are no helpful meta packages of dependencies, so you just have to create an environment with a big long list of all of GNU Radio's dependencies that you want to use. And so I maintain a couple of these lists on the wiki, or you can copy it from here for Linux in particular. And again, you make that environment, activate the environment, and then do your typical build steps passing the prefix path for conda. So once you're comfortable with conda, the next major step is to contribute back and add your packages to conda-forge. So let's say that you've got a conda recipe that works locally. Now what do you need to do? Well, I recommend following the conda-forge's documentation, which I've linked to here on the slide. But in general, you'll want to submit that recipe to their staged recipes repository. And you'll do that by first forking that repository on GitHub, and then create a branch within your fork to hold your recipe. And then you put your recipe in its own folder under the recipes directory and commit it. And if you haven't created a recipe yet, you can follow the example that they provided in the recipes folder to help you along. And then you'll submit a pull request to the main stage recipes branch. And then you'll iterate on that pull request into the CI builds pass. And once those are green, you can request a review from the staged recipes review committee. And if they accept and merge your package, then you'll be ready to move on to the next step, which is maintainership. Once a recipe is merged into conda-forge, a feedstock repository will be created to hold the recipe. The feedstock holds the recipe in the recipe folder of that repository. It also contains CI scripts for building packages in the cloud, and these scripts are maintained by a tool called conda-smithy. And what conda-smithy does is anytime the recipe changes, you'll want to run conda-smithy re-render, and re-rendering may update the CI scripts that are included in that repository. And you can configure conda-smithy by editing the conda-forge YAML file, which you can find in that repository. To keep a package updated once you have it as a feedstock, you need to know a few things, and one of those is that packages are built and uploaded on commits to any branch. So when you want to make changes, you'll want to do them from your own fork of the feedstock repository and submit pull requests to the main branch in order to check that the build works before you merge it. You can also use the build locally script to test the build locally on your machine. To help you maintain the feedstock, conda-forge provides bots that will send pull requests automatically whenever there's a version update for a new version of the source that is available, or if there's a rebuild that is needed due to dependency updates, such as when a global pin is updated. So like if GNU Radio were to be upgraded from 3.8.3 to 3.8.4, that might trigger a migration within the conda-forge community where packages are rebuilt against GNU Radio, the new version of GNU Radio following the dependency tree. So that's all I have. Hopefully this has been enough to get you interested in using GNU Radio and Conda, and hopefully I've given you enough information to be able to jump in and not feel lost. I think there's a lot of potential here for reducing some of the friction that happens with installing GNU Radio and out-of-tree modules. If that's something that interests you as well, and you want to get more packages into conda-forge, let me know and I'll be happy to provide guidance and co-maintain any package. I also think it would be a great idea to work on integrating conda with PyBombs so that some of what I've described in this talk can be automated. In particular, it would be good for PyBombs to adapt to a conda environment when building from source, or to find and install dependencies with conda, or to generate conda recipes from PyBombs recipes. So please, don't hesitate to get in contact with me if you have any questions. Thanks a lot for listening.